Okay, so this is the key to worksheet number 6. And on worksheet number 6, you're adding two rational expressions with different denominators, and you're subtracting two rational expressions with different denominators. All right, so remember, whenever you add or subtract rational expressions, the denominators must be the same. So we're going to have to factor the denominators and then find the LCD. Okay, so that's going to be the first thing we're going to do. So let's do number 1. So number 1, we have x plus 5 divided by x squared plus 10x plus 16. And you're adding 6 divided by x squared plus 4x minus 32. Okay? So first thing we're going to do is going to factor. So let's factor the denominators. So I get x plus, 8, x plus 2. Over here, that's going to be x minus 8, x plus 8, x minus 4. Okay? All right, so my LCD is going to be now, so your least common denominator has to include every factor you see. So I have an x plus 8, I have an x plus 2, I have an x plus 8, I already have it listed, and then I have an x minus 4. So my least common denominator has those three factors. So what I'm going to do now is I'm going to rewrite the two rational expressions with the factored form instead of the trinomial. So x plus 5 divided by x plus 8 times x plus 2 plus 6 divided by x plus 8 times x minus 4. Okay, now what we're going to do next is we're going to write equivalent fractions now. So this fraction is equivalent to what fraction with this denominator, with the LCD as the denominator. So x plus 8, x plus 2, x minus 4. Plus, same thing here. This rational expression is equivalent to what rational expression with that denominator? X plus 8, x plus 2, x minus 4. All right, so the way we're going to do this to write the equivalent expressions, so remember what we did in previous lessons was we knew that we had to multiply this denominator by some rational expression to get this. But what I did to the denominator, I got to do to the numerator because I need this to be a 1. Okay, so I have the x plus 8, I have the x plus 2, so I'm missing the x minus 4. So I'm going to multiply x minus 4. But what I do to the denominator, I do to the numerator. Now be careful. So you see that this is a binomial and you're multiplying by another binomial. So when you rewrite it, you got to put that in parentheses. Okay? You must put both of those in parentheses, and then you're going to be using a FOIL method. All right, and then let's do the same thing for this one. So over here, I have the x plus 8, I have the x minus 4, I'm missing the x plus 2. So again, I'm going to multiply the denominator by x plus 2. What I do to the denominator, I do to the numerator. Okay, so this numerator now becomes 6 times x plus 2. All right, so that's where we're at. So now the denominators are the same, but before we write it as one rational expression, let's go ahead and multiply these numerators out because we need to write those as polynomials so I can add them. So these must be polynomials for me in order for me to combine like terms. But always leave the denominators in factored form. So when I FOIL the numerator out, I get x squared. The outer is a negative 4x. The inner is 5x. I get positive x. 5 times a negative 4 is a negative 20, divided by the LCD. Leave it in factored form, the LCD. Leave it in factored form. Plus, over here, I'm going to use the distributive property. And so here I get 6x plus 12 divided by the LCD. Okay, now that I've written this as polynomials, I can combine like terms now. So that's the only reason why, that's why you want to multiply the numerators out, because you got to combine like terms. And so the denominator will stay, the LCD. All right, let's talk about the numerator. So I have, let's write this as one rational expression. So x squared plus x minus 20 plus 6x plus 12. So remember, this was a subtraction. you would need to put that in parentheses, right? Okay, but since that's addition, I don't need parentheses. Okay, let's combine like terms. I have x squared. X and 6x is 7x. A negative 20 and a positive 12 is a negative 8, divided by the LCD. Okay, now, remember the next step is you need to see if you can simplify this rational expression. And so to simplify the rational expression, I got to make sure that the numerator is factored and the denominator is factored. Well, the denominator is already factored, so let's look at the numerator. So in the numerator, I can factor this as x plus 8, x minus 1. And then the LCD in the denominator. And then notice I can now reduce the x plus 8s. Make sure you put 1s in their place. And that's all you can do. So the answer is going to be 1 times x minus 1 is x minus 1 divided by the product of these two factors. And leave it in factored form. Don't multiply the denominator out. Leave it alone. So there's your answer. So x minus 1 divided by x plus 2. So x minus 1 divided by x minus 2 times x minus 4. Okay? All right, lesson number 2. So number 2, I have x plus 12 divided by 2x squared minus 9x minus 35, and I'm subtracting x minus 4 divided by 2x squared plus 23x plus 45. Okay, so again, I'm subtracting two rational expressions. Before I can write it as one, the denominators must be the same. They are not. So I got to factor the denominators and find the LCD. So let's go ahead and factor the denominators. So when I factor the denominators, let's see what we get. So when I factor the 2x squared minus 9x minus 35, it looks like I get 2x plus 5, and then this will be x minus 7. And then make sure it's correct. So negative 14x and 10x is negative 14x, and 5x is negative 9x. And then 5 times negative 7 is negative 35. Over here, when I factor this, I get 2x plus 5 times x plus 9. Okay, so 18x and 5x is 23x. So now the LCD must include every factor you see. So I see a 2x plus 5. I see an x minus 7. I see a 2x plus 5, I already have it. And I see an x plus 9. So your LCD contains three factors. So now what we're going to do is we're going to rewrite these rational expressions with that denominator. But before we do that, let's rewrite this over using the factored form. So I get x plus 12 divided by 2x plus 5 times x minus 7 minus, over here, that's x minus 4 divided by 2x plus 5 times x plus 9. Okay, so again, now what we're going to do is we're going to write equivalent fractions for each of these two with that denominator. So basically, we're going to get this denominator, I want it to be this. So I get 2x plus 5 times x minus 7 times x plus 9 minus, and same thing here, 2x plus 5 times x minus 7 times x plus 9. Okay, so at this point, that's where you're going to write equivalent fractions. So I have to multiply this fraction by some fraction to get this denominator. So notice I have the 2x plus 5, I have the x minus 7, missing the x plus 9. So I got to multiply this by x plus 9. But what I do to the denominator, I do to the numerator. But be careful. You see, this is a binomial times, see this times a binomial. So you got to put that x plus 12 in parentheses. You must put the x plus 12 in parentheses. Over here, let's see what we get. So I'm going to multiply. So I have these two factors. I want to get these three. So which one am I missing? I'm missing the x minus 7. So I'm going to say times x minus 7 times x minus 7. So again, I have a binomial times a binomial. So I got to put that in parentheses when I rewrite it. X minus 4 times x minus 7. Okay, now at that point, I have the denominators the same, but I can't write it as one rational expression yet because I need these to be polynomials. Okay, so that way I can subtract or add like terms. So let's go ahead and FOIL the numerator out here and then FOIL the denominator out here. So that's going to be 2x plus 5. I'm just rewriting my denominator. And the numerator then, when I FOIL, will be x times x is x squared. The outer is 9x. The inner is 12x. And when I add them up, I get 21x, right? And then 12 times 9, if you're not sure, just use your calculator. But 12 times 9 should give you 108. All right? Okay, now subtract, and let's talk about this one now. X times x is x squared. The outer is a negative 7x. The inner is a negative 4x. When I add them up, I get a negative 11x. A negative 4 times a negative 7 is a positive 28 over the LCD, which is 2x plus 5 times x minus 7 times x plus 9. Now I'm going to write this as one rational expression. So I'm going to get 2x plus 5, x minus 7, x plus 9. And then just just put those two, and we're subtracting those, so put those two numerators here. So I get x squared plus 21x plus 108. You're subtracting this polynomial, so you got to put that in parentheses. X squared minus 11x plus 28. Okay, now let's get rid of the parentheses. So we're going to add the opposite. So I get x squared plus 21x plus 108 minus x squared. The opposite of a negative 11x is a positive 11x. And the opposite of a negative 28, the opposite of a positive 28 is a negative 28. All divided by the LCD. Okay, just like that. All right, now combine like terms. Let's see what we get. So the x squareds add up to be 0. 21x and 11x gives me 32x, right? 108 and a negative 28 gives me a positive 80, it looks like. All divided by 2x plus 5 times x minus 7 times x plus 9. Okay, now once you're at that point, remember you got to simplify this. So the question is, can I factor the numerator? Let's see. It looks like they're both have a GCF of 16. So let's factor out a 16 from the numerator. So I get 16 times 2x plus 5, right? 16 times 5 is 80. Divided by, and then the LCD, 2x plus 5, x minus 7, x plus 9. And then finally, we reduce. So notice I can reduce the 2x plus 5s, and that's all I can do. So the answer will be 16 divided by x minus 7 times x plus 9. And leave the answer in factored form. Don't multiply the denominator out. So that's the answer. So the answer is this. So again, if you need more space, just use your other paper. Just use your own paper like I did. So you have 16 divided by x minus 7 times x plus 9. So adding and subtracting rational expressions, especially when the denominators are all trinomials and you get at least one binomial in the numerator, can involve a lot of work. So just be careful though in the process because you could easily mess up with any of the signs and all that. So if it looks like it's not factoring out at the end, then probably you did something wrong. So just go back and kind of go through your steps again. Okay? All right, so that is the key to worksheet number 6 on rational expressions.